Hey, hi guys, this is Ankit again, and today we are going to talk about data center management. On this video, we will talk about basic introduction of the data center, type of data center, tier classification, evolution of the data center, and the key component of the data center, along with some key terms and other thing. So let's talk about first what is data center. So data centers are essential facilities that house computer system and related documents such as storage, telecommunication stuff, networking, some other things are there, and they comes in various types, each designed to meet specific needs and requirements. Each type of data center serve different purpose and industries, providing different solution or specific solution to meet the diverse needs of the organization. And see that why we need data center, because we need a centralized location where we can place everything. We have the reliability, redundancy, availability, everything, so we can serve our data or the service, or we can serve, we can implement our application, and that can be served to worldwide. So that's why we need the data center, and making this video is really important, because nowadays people are really centric to their domain label. If suppose a person is a Linux administrator, or a application architect, or the engineer, or administrator, whatever, they are not really aware of that, the whole infrastructure background, the background of that application, and that is really needed for better understanding. To deploy application, definitely you have certain requirement, and if you will have your basic understanding of the infrastructure, you deploy your application accordingly and get the best performance and everything. But if you are not aware of your architecture or your infrastructure, then what will happen? You deploy an application which requirement is ABC, but actually your data center can fulfill A and B services only. And even after deploying, doing the troubleshooting as well, you need to know your infrastructure so you can troubleshoot, you can limit the area of troubleshooting, where can be the bottleneck, where can be the issues. So it is very important. And further, for your disaster recovery, and even if you are a server, storage, or network person, while deploying new equipment, you should be aware of that, along with your troubleshooting and all. So that is data, that's why data center management is very very important, and people should be aware of that, along with other key technologies or nearby technology, to make them understand perfectly about their infrastructure, their work, their application, and etc. So on this slide, you can see that I have multiple pictures here, and let's go with first picture, and you can see the data center here. So this is the picture of one of the Google data center, and it could be a hyperscale data center, very big, where you can see that these three big buildings, and then you have your cooling, power source, generator, everything will be there. So this is just an example to show you guys how it looks like. It is in very big scale. So like you there are different type of data center, small scale, and a building and other, but it depend upon which type or tier class of the data center is there, and accordingly you will have your security, redundancy, reliability, downtime, uptime, etc, maintenance window and all. However, whenever you are in a data center, the security will be very high there. Whether you will talk about the physical security, definitely there should be different level. Gate level is there, building level, and under that server room and other stuff, there different level of physical security will be there. And then you are having other securities as well. So let's talk about some internal component of the data center. So here you can see that in second picture, there are racks are there, and you will have your blades. These are the blades are there, servers are there, where you are having cable, and all the cables of these servers going from above rails. Sometime it will from the below as well. Different type of cooling systems are there. So sometime you are having your cooling system on the tiles as well. In front of the servers you have your tiles, and from there the cool air is going on. And these are the big rails. You can see that the different level of rails are there. uh, the hanging rails where all the power cooling power, networking, and other cables will flowing. And same here you can see that these blade servers, and the engineer is working on the same. Not every data center you will see the scenario like this. You will have compact servers also, where in the front you will have a server, what I can say, that face, and in background you have all the cables and everything. But these are the very high end data center where it is just need the process and everything. That's why uh, you don't see the front cable, and these are specific as well, configured blades, and thousands of them with the rack. So it's come with, so it depend upon the configuration. So now let's talk about some internal component of the data center. So this is the picture of that which earlier I was discussing. So let me first do this, and then let me start. So this particular picture, you can see that there is two architecture there. One is the data center room, and one is the power room. So data center room, if you can see here, there it is a small data center. There is three rows are there, and the 10 racks are there. And cable, it is not showing here. Mostly it should be having their upper hanging rails where cable will go, and sometime internally also it will go. You have your AC unit where the air circulation is happening, and normally it is from the above it is happening, but you will have your air blow from the below as well, where you will have different kind of tiles for flowing. You have your power units there, the distribution model which distribute the power, and jumpers are there under that. You will have your patch panels on the rack level, so from where all the like server cables connect there, but whether it is in below or above, and then it will go for the network cable. It will go, you will have your PDU units on the rack where all the power cable will connect, and it will go below or the above. It depends like which kind of or how it is configured. Then let's talk about the power or backup room. So here you can see you have a transformer for electricity, you have generator for your backup, and at the same time you have your UPS unit and the battery back for your UPS backup. So whenever light will or electricity will go off, automatically your generator will start. But in the meantime, there is a friction of second gap and all, and that's why for continuity, these UPS backups are there. Mostly, it will give the power to servers only, not the AC, because these needs very much loaded and they need too much power. So mostly it will be not there. And then like generator will be give power to everything when it will start. Suppose it will go fail, then mostly it depend upon the tier of data center. You will have multiple redundancy for that as well in every level. So it depend upon your data center class, and like accordingly it will provide the service and the cost and everything. So this is the data center. And suppose you are a application admin, okay, and you are working on your application, but you really don't know the below devices or the layer what are there. So you should be aware of that and how it is situated, how the cablings are there. Suppose so you have application, it is on one server, you will have your database server, you will have your storage will be there, the networking part will be there, and then these servers are situated, or the storage network devices are situated on these racks. And then these servers need a specific power, cooling, and other stuff to process, right? So you should be aware of this, how it is situated. In the same time, when you will know that, you will know how these are connected, and all the details of that, which will be really helpful for you while you are deploying your application, while you are doing troubleshooting. So you are know, or you should know, which kind of capability you have in your data center that will fulfill or not, or if some issues are coming on the latency or the IOPS bandwidth or anything, where you need to look. So it is very important in the both way. You should be having the knowledge on the same. So let's go further here. Now we will talk about evolution of data center. So you can see that the main it started from 1946. So there will be ENIAC was there. So electric numerical integrator and computer was the first electronic general purpose computer. It was digital and capable of being programmed to solve a large class of numerical problem. So this was the start. Then you can see that 1971 Intel CPU came, and first commercial available microprocessor was there. Then the 1978 SunGuard availability system become the first major US commercial disaster recovery business. And now still you know that SunGuard is one of the biggest vendor for DR solutioning. Now 1981 the personal computer came, and it was a PC capable hardware platform, and it changed a lot of stuff, I can say that. And then early 90s microcomputers came, and it was a major change which happened, and it started to like old computer rooms and were being called. So it was started to place on the computer rooms, and were being called data center. And in mid 90s the boom of data center came during the dot com bubble, and companies needed fast internet connectivity and non-stop operation to deploy systems and establish a presence of the internet. And then the major change about the 2002, where Amazon Web Service began deployed of a suite of cloud-based service which included storage and computation. And then the 2007 Sun Modular Data Center is a portable data center built into a standard 20 feet SIP container manufactured and marketed by Sun Microsystems. So we'll talk about the micro data center. So it is in a container and it is modular. You can go here and there, and you can, if you have somewhere some deployment which you need to show, or sometime your data center needs some extension due to some activity or something for a time being, these modular data center is really helpful. Then 2013, Google invested 7.35 billion in its internet infrastructure. This is spending was driven by an expansion of Google's global data center network. It represented the largest construction effort in the history of the data center. And then 2020, 2015, over 575 million new servers are deployed every year. After that, there are an estimate 45,000 plus data center in the US alone to meet the growing demand of new application and services. Servers need to be deployed at an increasingly faster pace, and larger number new servers are deployed. So there are lots of changes happen, but mid 90s was a, crucial part, and then when the cloud services introduced. So these are the key points along with the microprocessor and other stuffs are there. So there are other things also happen. So when you will go and search that, you will most probably find those details there. So let's go on the next slide. These are some of the terms of the data center which we should be aware of that. Just like here you can see that green field. So it is a facility built from scratch on a completely new site, and it is a state of the art facility where you will have everything perfect kind of. You will have all kind of latest design and everything, and you will deploy. And brownfield is that, like there is an old data center where we are repurposing or upgrading an existing building or facility to meet modern data center standard. So that is there. And then the redundancy is there. So what is redundancy? It is a duplicating critical component and system to prevent downtime in case of failure, when you will talk about in a data center term. So different kind of redundancy is there: n plus 1, 2n, 2n plus 1. And like one system is there, you don't have any redundancy. Here you have one system but you have redundancy. If something will go happen, this will help. Then you have two, you have a cluster system where you are having two system live there, and it is working. Or even like one active or passive will be there. Now 2n plus 1 will be there. Then you are having the redundancy, as well as you are having two component cluster component in a data in any application, any servers, or anyone. So if it something happen on this particular server, it will go to another server, and then if there's something else happen, then it will go for the redundant one. So this kind of classification you have, and mainly it is agency over, you are having tier as well. So it is a tier 1, 2, 3, 4, this kind of facility. So we'll talk about further on the later slide for on this. Now reliability. So reliability is the meeting functions over time. So you have a data center where you are having reliability, like whenever will be required, or like next 5 or 10 years we have built it, and you have reliability, like whatever function or whatever requirement I need over period of time, it will fulfill. So that is the reliability. It is very important. Then the availability, amount of time system is functioning. It is not system is up, like it is functioning actually. Up, sometime up is also people measure that, but on the application level, it should be like not server up, it is the application, the function should be. Now the uptime, time that equipment and system are available to perform functions. Downtime is there, time that equipments and systems are not function. Then mean time between failure, it is also important, the average time between failure of a system or component. So once a component got failed and then recover, so what is the failure time in between that? Then mean time to repair, the average time required to repair a failed component or system. So that should be, let's suppose one server got crashed, so to replace that, like how much time, average time it will take to repair or like to replace it. So there are much different kind of scenario can be there. So power uses effectiveness. So how we can effective do the power uses effectiveness, like in any way, like we can do that. It is required, like we definitely need efficiency in every way on that. So any kind of efficiency will be there, it will come under the PUE. Then TZZ is there, the green grid. So it is an institution which monitor the efficiency, also the green efficiency you can say, and everywhere it is, whether it is power efficiency, cooling efficiency, other, there are a lot of other efficiencies are there all time of they are doing that. So UTI uptime institution is there, so this is also monitor the uptime and setting the standard of the uptime on the type of tier of the data center. And you can go further or go through the terms and read on the uh, internet on the same, so you will get more details. So now let's go further and talk about the type of data center. We already talked about the what is data center, so will not again go there. But when you will talk about the type of data center, the first will come as a enterprise data center, which is owned and operated by individual organization to meet their specific IT infrastructure needs, typically located on premises or off premises, depend on factors like power availability and security. And large corporation, mainly it's used like Bank of America, Walmart, and many other companies are there which is having their enterprise data center. Nowadays people are moving to cloud as well, but still there are lots of enterprise data centers are there. So that is the first one. Then co-location data centers are there, where third-party vendors giving the facility of the data center, where multiple organization can rent the space of or for their servers and other component. Uh, Provide shared infrastructure such as power, cooling, and security. So third party vendor will supply the power, cooling, and security, and you will have your space. Suppose this is the data center, so this is the chunk of other different organization, they have their chunk and they place their racks component. They use the power, cooling, and security. It is the physical security, you can say that. And like logical security, you are managing with your firewall, your network, like from where it is coming, and they are having their features and all. So those will be on the logical level, on the how you have your configuration will be there. So in this way, what will happen, you don't need to maintain data center, own that, or high cost of the building. Because when you are having a building of the data center, there are standards are there, you need to maintain that building or that data center accordingly. You should be having that kind of cooling, power, security, physical security, different level of the security will be there, machines are there, and then you need to maintain that whole building, electricity will be there for whole building as well, not even for the data center and other more. That's why people don't go with that, the small organization or like an organization which is having small requirement in a area or in a country, because you know that when you are deploying a data center, the latency is really a critical thing. So which kind of performance and latency you are having. So that's why people large organization distribute their data center in between multiple countries. And but nowadays, when you are having cloud, people are going on the cloud as well. And they are using that. But whoever having their on premises, it doesn't matter, it doesn't need it every time they need to deploy a data center and everything, they just rent it. There are third party vendor on that. Now the hyper scale data center, so massive facility designed to support the scalability. It will be a robust and large cloud service provider like Amazon web services, Google Cloud, and Microsoft Azure they are using. So they are very big. All kind of latest technologies are there, and all kind of power, electric, cooling, the building security. You will think about it will have everything redundant and all. So it will be very massive scale and like a super availability data center. Now you are having edge data center. So edge data center is also a smaller facility located closer to the end user to reduce latency, as I said earlier also, and improve the performance. Sometime you are having a small organization, even big organization, but you have application that require real-time data processing, just like IoT devices and autonomous vehicles and all. So how you will deal with that? So you need nearby in that country, you need a data center. So that small data center can be called as a edge data center, depends upon that. Now the modular data center. So modular, as I said earlier, like it is a container based, so portable and scalable, like unit that can be deployed quickly to meet immediate need, can be added to an existing data center or use in remote location where building a traditional data center is not feasible, offer flexibility and rapid deployment for various application. So it depend upon the requirement and all. Like if you have a data center where instantly you required something, you can add that modular data center. Or somewhere you don't you can't have a traditional data center, so you can, sorry, so you can have this kind of traditional modular data center which can be work. Now managed data center, so this is also like operated by third party service provider who manage the infrastructure including hardware, software, and networking, allow organization to focus on their core business while outsourcing the management of their IT infrastructure, suitable for business that prefer not to handle the complexity of the data center. So suppose earlier the co-location where you are having your data center person as well, who is visiting and doing everything, and you are managing your hardware, software, and networking. But here in the managed data center, you don't know. It is just a cloud like facility where you are having services offer. Okay, so different kind of services you can take, and you can bother about that service. Nothing you need to bother about in the background. Whatever is requirement, you can give them that kind of bandwidth, IOPS, or whatever will be there, redundancy, everything will be there. And that will be managed by the like third party vendor. So these all are the types of data centers. Now let's talk about the tier classification of data center. So data center tiers are a standard, it's a standardized classification system, okay, that indicates the reliability and performance of a data center infrastructure. The Uptime Institute defines four main tiers, uh, each with a specific requirement and capability. So as I earlier said, there are total four classification of there on the tier. Tier 1 is a basic capacity, where you are having infrastructure like basic site infrastructure with limited protection against physical event. Redundancy, no redundancy for power and cooling. You will have your single unit for power and cooling, and if something will go wrong, if your electricity go wrong, and in the same time your dc will or the generator will go on, no, go wrong, then ups can't handle for much time, and then you will have heat and other stuff, and there will be an issue. And even on the component level, you don't have that kind of redundancy. Definitely on the device level, the power redundancy you will have, but this power and cooling data center level we are talking about. So and in the same time you don't have a secondary system to do the failover and then do the maintenance and repair. So there will be downtime, and that's why the expected uptime will be 99.67%, and total yearly downtime will be 28.8 hours. So this is also too much for the data center environment. Definitely there will be some incident and other thing will be there, but even on the physical events or something else in a different type of data center, you have your dr environment, you have some other redundancy, and everything will be there. So in that way you can save your services. Now the tier 2, that is the redundant capacity component, where includes like on the infrastructure level redundant critical power and cooling component. So it is a n plus one redundancy, and partially redundant redundancy allows for some planned maintenance without downtime. So it is not like everything is redundant from here to there. So still while doing the maintenance activity, there will be can be downtime. So you can see that can handle maintenance activity without shutting down the entire system, but it will be not for each and every devices mostly. And expect uptime of 99.74. So still you will have a like 22 hours of downtime per year. You can have that. And the ideal for a small to medium sized business that need more reliability than tier 1. So it needs more reliability, but don't want to spend that much of money, because redundancy, it will be a too much cost. Suppose you are having one plus one redundancy, okay. So what will happen, for every component you are having two component for everything, and it will just double cost for everything. And it will not only double the cost of component, it then the cooling, power, people who manage that, everything will be grow in along with the size of the room, data center, whoever is there. So there are lots of cabling, uh, other thing, a lot of things are there. So definitely it is a costly. So that's why the small businesses go for the tier 2. Now uh, concurrently maintainable, tier 3. So fully rendered power and cooling system for everything, allow for maintenance without affecting operating operations, ensuring continuous availability. System can be maintained concurrently without downtime when maintenance happen. Expected like uptime 99.982%, and you will see like only 1.6 hour of downtime per year. Suitable for large enterprise with critical IT operation that requires like that. You can't say banking, but yeah, definitely there are lots of other pharmaceutical and other companies are there which is really high availability they require, so they go for the tier 3 kind of. And even for banking also, people or other like commercial side, they go for that. But most of the high end, they are going for this one, the fourth one, the fault tolerant. So you will have your 2 plus 1 redundancy for all system, including power and cooling. So what will happen, on the equipment level you will have 1 plus 1 equipment, you all the equipment will be in the cluster. And like you will have a double like system. If it is not, it will not, mostly it will be in cluster, so it will fail over. So it will handle here. And suppose if something will go wrong here, it will fail over, this will have also an issue. Then you have one more system here for the redundancy. So it is a very high end data center, and can sustain operation even during unplanned events or failure. So if some kind of unplanned events happen or failure happen, even on the both the initial components, still there will be a third one, so who can manage that. And you can see that the expected uptime 99.995. So this is too like really high, and you are having only on a year, you are giving facility to have only 26.3 minutes of downtime per unit per year, sorry. And ideal for the business with a zero tolerance for the downtime, such as financial institution, as I said, a large e-commerce company that really required a very robust system. And if something else will happen, that can be manageable. In the same time, suppose some kind of I don't think people are making data center near sea or something where tsunami can happen, but earthquake happen anywhere. So you will have your secondary site ready in the same city, or how it is like planned, and where you are having your most of the services which can be available in the time. So there is a RTO and RPO is there on the disaster recovery time object and recovery point object. So the time, how much time it takes to recover an application, that is the recovery time object. And when you will talk about the point object, so how much data the client is allowed to lose. So it can be possible you have a 1 hour of RPO but 24 hours of RTO. That means you lose 1 hour data. That means mainly the syncing the data, where the sync is happening. So that means 1 hour the data you can lose, that is your syncing is happening late or whatever is configured, but still you can use 1 hour of data. But making that application functional, you have 24 hours to do that, because there are lots of other things will be there. So normally when you are having an application which is lose one, and you will have I can say 6 to 12 hour, but it depend upon that RTO and RPO. So and accordingly you have your another data center and you are doing your work. So this is this extra I have added. But yeah, on the disaster recovery you should aware of the data center function, how it works and all, and how the configuration of WAN. And then sometime when you are having a data center on the DR, you are not able to recover everything. It depend upon that, sometime due to the cost and other thing. They are having a small environment in the data center, and they are just configuring or have the things which can recover, which is really critical, and continue their services till the time they will recover everything or whatever. So it depend upon the environment. So I am hoping this session will be helpful for you guys. And please comment, like, and give your feedback on the same. If there is any improvement or anything is required on this video, or like the way I'm teaching, just let me know. That will be really helpful. So that's all for today. Thank you guys.